Welcome to part 4 of the series entitled Physics in Action. In part 1, an overview regarding the formula on law on tensions was briefly discussed. And in this video we will go into the details of solving for sound waves. The formula is a simple ratio and proportion concept where lowercase f represent frequency produced by a string, while the uppercase f is the exerted or applied pressure on a string. Somebody may ask, what's the apostrophe for? Lowercase f and uppercase f soft prime relates to another string applied with a different pressure. Thus, the formula is trying to utilize the relationship of two strings, that is, comparing a pair of strings. Specimen 1 refers to string number 1 while specimen 2 refers to string number 2. There are no secrets here. The trick is, when you gain information about one of the strings, you get to find the other string's information. Now let's go to the calculations. Notice that the formula has a square root involved. And I have already discussed that in one of my earlier videos. For those who still doesn't know how to find the square root of a number, please click on the link shown in the description below. Or, you can browse against the XG playlist video offerings. For simplicity, calculations and solutions will be based on cross-multiplication in concurrence with transposition technique. For example, just to juggle your memory. This is the given ratio. Naturally, 25 will be multiplied by the unknown x, then goes into one side of the equation, then 10 multiplied by 50 on the other side. Transposing 25 gives you the answer, 20. One thing to remember though, there must be at least 3 variables known in order for the formula to work. 2 variables will not do. Much the least with only one. Now you may ask, why is this so? I will tell you later in the video. For example, you may have the frequencies of both the strings. Inadequate. You may have the frequency and corresponding applied force of one of the strings. Inadequate. You may have the frequency and corresponding applied force of the other string. Inadequate. Here, you got 3 variables. Now that's a go. Before we go further, I want you to imagine a cord or even a steel wire being stretched ever so tightly and then hit on its surface, creating a sound. Pianos and guitars behave in a similar manner. With this process in mind throughout the discussion, it will help you better understand the concept. Some more trivia. Most of you may be wondering how chords work. And some may be asking why most known chords are being named with a single name or designation, when in reality it has multiple fundamental notes. There is a scientific parallel explanation to that. Let us say that a particular chord like F minor or any chord at all propagates into the air as a constructive type of wave, composed of its constituent notes. A resultant single equivalent wave will ensue. Let me repeat that. A resultant single equivalent wave will be produced. The very reason why the chords G, B and D when played together creates chord G. Because no matter what you do, it will predominantly sound like a G in a particular set or octave where it belongs. Let me rewind that. Observe. Next. I want to direct your attention to this table. Notice that the notes C4 and C5 are the only two entries with data on their columns. Also, take note that C4 to C5 makes up one octave, which is actually Do, Re, Mi, Fa, Sol, La, Ti, Do. Do you think these few information at hand can suffice in finding the forces and frequencies of the other remaining notes? I mean, can we ever fill this table up with the required data? For example, your professor wanted you to find or supply the missing data using only these four values. Do you think it's possible? Well, the data available helps but not quite. Remember that you need three variables in the formula in order to solve it. To demonstrate your situation in the classroom, let us solve for D4 first. Looking at the table, we have 261.626 as the frequency F, and 50 newtons as the corresponding applied force F, belonging to the same string C4. But then, we don't have F soft prime of the other value for string D4. During this time, we are already trying to compare C4 and D4. We need three data. So, what do? We go to google.com and type frequency of note D4. Then it will show around 293.665 Hz. And we write it down. Now, we have enough data available to us to find D4. Substitute the value in the formula. Solving for the applied force, we divide 261.626 by 293.665 to get 0.8908. By transposition, we have square root of F equal to 7.07 over 0.8908. This gives us 7.9366. Then by squaring both sides of the equation to eliminate the square root looming over f, while exponentially increasing 7.9366, we have 62.99 newtons as the force F. That means, I have to hit the string that hard in order to get the sound of D4. We supply found solution on the table. Next, as you can all see, we still have a long way to solve for the other notes E4 to B4. So brace yourselves. Suppose we want to find the data for E4, but this time using the data of string C5. Just in case you are wondering, you do know that we can find the data of all the strings here using only the data on C4. But just to make things a little bit interesting, let's use C5. Everything that follows at this point become mechanical. Step 1. You Google it. Step 2. Substitute the values, and step 3. Solve for frequency F. And eventually, you will end up with these data. I mean, you can try it with a calculator if you want. As you can see here, same procedure follows to find F4. This gives us 88.99 newtons. Same process goes with G4. We Google it. Substitute values, then solve for F, giving us 101.08 newtons. Same process goes with A4, giving us 141.42 newtons. Same process goes with B4. I am reiterating here that you need only the data of C4 to find everything. As you all can see, how possible it is to find multiple values using this formula, whereas if you remember we started only with one row of data. C5 was just an auxiliary data. B4 has 178.19 as the applied force. And finally, we reached C5. Earlier, I said that you just got to have a minimum of 3 variables in order to solve law on tensions problems. This is due to the fact that frequencies of the different chords must be tuned at their precise values. If any student attempts even to perform extrapolation, then all the values will turn out wrong. There is no guesswork in math. Guessing is forbidden in math. Always look up values of data under the frequency F column. There is another shortcut to reproduce this table. However, that may have to wait for another discussion in another video. For now, Google it. It is an illusion to think that light waves are equally spaced with regards to their spectrum when they are not. Even when looking through a rainbow, their width patterns does not really reveal equal spacings between them. The same goes with sounds. Implications. 1. As you move up one note to the other, the higher the pitch. 2. Higher notes require greater pressure F soft prime. Thus, the bigger the ouch as you move up a notch in a fretboard. Guitarists form calluses on their fingers due to this. That's it for today. See y'all later, everyone.